right before us we have got two analog instruments. We have the ammeter. We call it the ammeter because it is having that A, and we know all that the ammeter measures current. We have the voltmeter because of that V. That is what makes us know that this is a voltmeter, and the voltmeter measures voltage. We also know that the ammeter during connections is always connected in series with the circuit, and the voltmeter is always connected in parallel to the device whose potential difference is going to be measured. Now, if you look at this closely, sometimes, not all times, but on some ammeters, for example, like this one, there are two scales. There is the upper scale and the lower scale. Likewise, this voltmeter, if you look at it closely, it is having an upper scale and a lower scale, or we call it the outward scale and the inward scale. So now when you are using these instruments, and how do you determine which scale to use? So today I'm going to explain how you determine the scale to use. Now, so if you look at this ammeter, it is having terminals where we get to connect the wires from the circuit. Now I will be illustrating using this. This is a dry cell. It is having this as its negative end, and this is the positive end, and we are having wires getting out of this dry cell. So we are going to use this dry cell to connect to this ammeter so that we are able to determine how we connect this. Now if you look at this one, it's having a negative terminal right there. It is labeled negative, so it means that we connect the negative terminal of the battery to that point. Then we are having these two knobs. Now these two knobs are both red, but these two red are the ones where we get to connect the positive ones. Now it means that we can either connect the positive terminal right here, or we can connect it right there. The same thing with this voltmeter. It is having two terminals that are red, and this is where we are going to connect the positives. The negative is the black one, and it is labeled negative. It is both labeled negative and it is black. Well, in some voltmeters it's not labeled, but it is just black, and also in some voltmeters these red terminals are not labeled that they're supposed to be. It's supposed to be where you put the positive wire, but they are red. So just know that when it is red, that is where you're supposed to connect the positive terminal, and when it is black, that's when it's supposed to be, that's where you connect the negative terminal of the battery. So let's talk about where we connect the positives. Looking at these two, we have right here 3 volts and 5 volts. As I connect the negative terminal to this port, I have the option of connecting the positive terminal of the battery either to this terminal that is having 3 volts or to this terminal that is having 5 volts. Likewise on this ammeter as well, as I connect the negative terminal of the battery to this port, I have the option of connecting the positive terminal of the port to either this or that port. Now, how do I choose which port to use? It depends on what scale you want to use. Looking at this scale on the voltmeter, we are having the outward scale, the upper scale. And the outward scale is running from 0 up to 3. So it means that for this full scale deflection of this scale, this will deflect up to 3. If we are to look at this scale, the downward scale, it's running from 0 up to 5. So it means that at full scale deflection, this thing goes up to 5 when the thing is fully deflected. So it means that for me to determine which scale I'm supposed to use, when I connect the negative terminal of my battery here, if I connect the positive terminal of the battery to the 3 volt terminal, it means that I am choosing to use the upper scale because it is the upper scale that is having the 3 volt terminal as the full scale deflection. Likewise, if I connect the positive terminal of the battery here at the 5 volt terminal, it means that as I am reading my voltmeter, I am going to use the lower scale because it is the lower scale that is having 5 volts as its full scale deflection. So it is the same thing even as I'm using this ammeter. If I connect the positive terminal of the battery to the terminal 1, it means that I'm going to use the upper scale because it is the upper scale that is having 1 ampere as the full scale deflection of 1. And also, if I connect to 3, it means that as I'm reading my ammeter, I'll be reading using the lower terminal, the lower scale, because it is the lower scale that is having 3 as its full scale deflection. So let's try and do it practically. This is a voltmeter right here. Let's try and measure the voltage of this cell. This right there is the negative terminal of the cell. This is the positive. So we are going to get the negative terminal and place it at the black spot. So when we connect it right there, our scale is still at 0. So we get this. Let's use the 3 volt. So we connect at the 3 volt terminal. So when we connect it to the 3 volt terminal, our voltmeter has been deflected. It is 1.1, 0.2, 0.3, 0.4, 0.5. So this cell, this dry cell, so as you can see, it is, so it means this is a 1.5 volt dry cell. So like you're seeing, the voltage here is 1.5 volts. Now if I wanted to shift this from here to there, it means that I'll be using the lower scale. So let's see, if I put it on the 5 volt terminal, what will the lower scale read? Connecting it to you look at the lower scale that is having a full scale deflection of 5, it's going to read 0, 1, 1.5 volts. So meaning that where you connect the positive part of the battery, the positive terminal of the battery is going to determine which scale you will be using in your measurements. So now we are going to go ahead and experiment this still on the ammeter. Still on the ammeter, we are going to connect the negative part right there on the black spot. Then again, we are going to use, we shall connect, if we connect to the terminal number 1 where it's having 1 written, it means that we shall using the top one because it is the one having a full scale deflection of 1. So we shall be using that as our scale, and it's the one we shall be reading. So if I'm to connect 1, how much current is passing through? Now you realize that when I connect to 1, the deflection goes even beyond the maximum 1. It means that the current flowing is too much and the scale on top is too limited to measure the current. So it means that using this terminal won't be favorable for me to measure the current, so I'll remove it and consider to use the lower scale because the lower scale is a bit bigger. So I'll connect it to 3. And yes, when I get to connect it to 3, I find myself having 0, 1, 1.5, 1.6, around 1.8, 1.9 amperes. So the current flowing through here is 1.9, around 1.8, 1.9 amperes here. So that's how we use this analog voltmeter and ammeter, and that's how we measure these scales. Now, if you realize also on these scales, it is having, for example, from 0 to 1. This is running from 0 to 1, then from 1 to 2, then from 2 to 3. You realize that from 0 to 1, there are 10 small graduations, 10 small divisions. So for me to be able to find the value of each of those small divisions, it is going to be 0 to 1. So it means that 0 to 1, that is 1 divided by this 10. 1 divided by 10 gives me 0.1. So it means that each small division there is a value of 0.1. That's why it's going to be 0.1, 0.2, 0.3, 0.4, 0.5 is in the middle, 0.6, 0.7, 0.8, 0.9, then 1. It is the same thing with down. Now, not all scales are going to be having it that easy, that every small division is going to be having 0.1. For example, let's look at this scale on the ammeter. You realize that every after 10 small divisions, you're having 0.2. Then after 10 small divisions, you're having 0.4 until you're having 1. So it means that the value of these small 10 divisions between 0 and 0.2 is not the same as this one. This one we were able to notice that it is 0.1 because it is 1 divided by the 10 to get 0.1. It's the same thing in the lower scale. Every 10 small divisions goes up to 1. After 1, 10 small divisions goes up to 2. So it means that every small division there, is the value of 0.1. And it is even the same with the lower scale on this ammeter here, that when you move from 0 to 1, 1 divided by these 10 small divisions, you get 0.1 as the value of each of and every small division. But now when you look at this top one, it is moving from 0 up to 0.2. So after 10 small divisions, you go to 0.2. So what is the value of each of those 10 small divisions? You're going to get 0.2 divided by 10. And 0.2 divided by 10, it means it is 0.02. So if it is 0.02, it means that for each and every small division on the top scale here is going to be 0.02. So let's say you connect your current and it reads somewhere in between. Let's say it goes up to 0.4 and it goes up to that point. So now that would mean that it's going to be 0.4 plus 1, 2, 3 small divisions. And so you'll get those 3 small divisions and you multiply them by 0.02 because each small division is equal to 0.02 and you'll get your answer. So these are the 2 scales we're talking about. We're having this one. This is the simple one. The one where let's assume that as we were measuring, let's say, our voltage or our current, and we got the pointer pointing at that point from there, right? So if the pointer was pointing at that point, what is the value of each of these small divisions? We say that to get the value of each of those small divisions, we simply know that this is running from 0 up to 1. So to get the value of each, it is 1 divided by the 10 small divisions, and it's going to be 0.1. Now since it is 0.1, it means that to measure this part where this pointer is pointing, it means it's going to be 1 plus, how many small divisions are there? There are 1, 2, 3. So it is going to be plus 3 small divisions times the value of those 3 small divisions, which is 0.1. So it's going to be 1 plus 0.3, and that's going to give us 1.3. So this is simple. You would simply say it's 1, 1.1, 1.2, 1.3. And that is how we get it if we are to use calculations. Now, not all scales are going to be this easy that you'll be able to, if you're capable of just reading them directly without having to calculate. For example, let's look at this scale here. If you look at this scale, it is running from 0 to 0.2. It means that for each of these small scales, the value of each of those small scales is going to be, we shall be saying it is 0.2, divide that by this 10. And that's going to give us 0.02. So it means that for each of these small divisions, it's going to be equal to 0.02. Let's say our pointer pointed at that point. So it means that to get the value here, it's going to be, measuring from 0, it's going to go up to 0.4. So it's going to be 0.4 plus. Now from 0.4 to where the pointer is, how many small divisions are there? We have 1, 2, 3. So there are 3 small divisions. So it's going to be plus 3 small divisions. Multiply the 3 small divisions by what is the value of each of those small divisions. So the value of each of those small divisions is 0.02. So it means it's going to be 0.4 plus 0.06. So it means that the value at that point is 0.46. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.